So in this example, we're going to apply Gaussian elimination to the following matrix. Now, the key here is that we apply row operations to swap the entries. And then there's this interesting formula here where we have Rij times Rj, or Arj times Aij inverse. And what this here is we have to use row I to zero out row J. And this Aij inverse allows us to make whatever my pivot row is a 1, and then I just simply multiply it by the value of the other row. Now, it may seem complicated, but once we see what we're doing, it doesn't feel too complicated very quickly. So first, what we're going to do is we're going to take this matrix. Take the augmented matrix 1, 2, 0, 3, 3, 2, 0, 0, 6, 6, and 1, 1, 4, 3, 5. And we pick our pivot, which is going to be this value 1 here. We're going to use it to zero out the second and third rows. To do this, we're going to take R2 minus something times R1 to replace R2. Okay. And that value of R that we were multiplying here is the value of R2, 2, times the multiplicative inverse of R1, which is 1 over 1. Okay. Same thing for R3. R3 minus, the value here is 1, so it's 1 times 1 over 1. R1 replaces R3. The first row isn't being touched, so it doesn't change. Now the second row, what am I doing? I'm subtracting 2 times R1. So I take R2 and I minus 2 of R1. So I get 0. Then I get minus 4. And I get 0. And I get 0 because 6 minus 6 is 0. 3 minus 6 minus 6 is 0. Here I get 1 minus 1, 4, 0, 2. And this entry here, sorry, is going to be a 0. Now you can see I've cleared out the first column. So I've picked my leading entry. I've put it in the right spot. I've cleared out the first column. Then I go to the next column and I repeat this process going down each row. I've done the first row. Now I go to the second row. I find the column to the right. That's the first non-zero entry, and I repeat. Now, when I'm doing this, when I look to the right, I am not allowed to use this row anymore. I have to use the next row. Okay, so now I'm allowed, when I look on row I need to either use this minus 4 or this minus 1. Okay. And here, what we're going to do is we're actually going to take minus 1 here. And that's the entry we're going to use. And we could use the 4 or we could use the minus 1. It doesn't matter. We're going to pick the minus 1 and we're going to exchange the rows. Okay. Exchanging the rows gives the following matrix. R3 swapping with R2 gives the matrix 1, 2, 0, 3, 3, 0, minus 1, 4, 0, 1, 0, minus, or 0, minus 4, 0, 0, 0. From here, we eliminate everything below. So we're going to take R3, and we're going to minus that minus 4 times 1 over minus 1. The minus 4 comes from the leading term. The minus 1 is the multiplicative inverse of that minus 1. R2 replaces R3, giving us the matrix 1, 2, 0, 3, 3, 0, minus 1, 4, 0, 1, and 0, 0. We're subtracting 4 of those, so minus 16, 0, minus 4. And this here is our row echelon form. We are in row echelon form. My basic variables, if I look at it, if I look at my original system, I haven't defined the basic variables. So the basic variables are going to be my first entry, second entry, and third entry. So it's if the system is X, Y, Z, W, the basic variables, let X, and we'll relabel this W, X, Y, Z be a solution. Then the basic variables are W, X, Y, and the free variable is Z.